Hi, in this video we will see what is overfitting and underfitting. Before diving into overfitting and underfitting, we must understand that machine learning algorithms tend to solve the problem so that they can generalize on unseen inputs. Generalize means how well our model performs on inputs which are new for our model. In other words, how well our model predicts the output if we use a new input which was not there when we trained the machine learning model. To check how well our model generalizes on the unseen inputs, we split our data into two parts, the train set and the test set. After using the train set to learn the model parameters, we use the test set to finally evaluate the performance of the model so that we know that the model is able to predict outputs for the unseen inputs. Because otherwise, it's just like a database. We can look at the input which we have given from the database, find the corresponding output and just use that as a predicted output. But that's not what machine learning models tend to do. Machine learning models want to generate outputs for unseen inputs, and that's why it is very important that they generalize on the unseen data. So in case of overfitting, the model learns a very complex relationship between inputs and outputs, which is not in fact the true relationship between input and output. Such a complex relationship is learned usually because the model also learns the noise which it should have ideally avoided. And such a model performs very well on the training data, but when given the unseen data or the test data, the performance drops substantially. So for example, here in this case, let's say our model learns the following regression line. So this is clearly a case of overfitting because we can see that the generalized learning algorithm would had learned a regression line something like that. So this is the actual regression line which we wanted our model to learn, and the red line has learned the noise from the noisy data points. As we can see that this is quite an outlier because it lies quite separately from our other data points. So basically an overfitted model learns the noise from the data, and such an overfitted model does not perform well on unseen inputs because it has not understood the general pattern between inputs and outputs, which is represented by blue line here. Let's say we are given an input point to be this x1. So here we can clearly see that ideally the predicted output should be this point marked in orange, but in actual our overfitted model would predict the output to be this value which it learned from this outlier here, and which would not what we would expect our model to predict. We will expect our model to predict a value somewhere here. So this is the right value and this is the overfitted model prediction. Hence, if our model is overfitted, we need to make our model simpler so that it is able to learn the generalized pattern between input and output. On the other hand, in case of underfitting, the model is not able to learn any kind of relationship between input and output at all. The model performs poorly on both the training data as well as test data. For example, let's say this is the kind of model we learned. So we can clearly see that the model is just simply predicting outputs which are not anywhere close to real outputs. So a more moderate kind of prediction which we want would be the blue line. So basically the outputs which we are getting from the green line for these inputs is far away from the actual outputs for these inputs. Hence the model is not at all learning the relationship between input and output, and this is clearly a case of underfitting.